This lesson is called Optimal Values in Economics, and what we want to be able to do here is, I've given the rather vague learning goal here of solve problems involving the maximization of revenue. What we're going to take a look at is one specific kind of revenue problem, and it's the type of problem that you've already encountered before back in grade 10 when you were studying parabolas. And we'll look at how you set it up and how you solve it. And this problem is going to kind of act as an introduction to what we're really going to be doing in the next lesson when we look at a more general kind of business and economics applications. And at the end of this, I'll talk about some of the limitations of the method that we're going to use to solve this problem. So here's our problem. A large retailer selling mountain bikes has found that for each $20 reduction in price on the Rockhopper model, an additional 2 bikes are sold each month. The Rockhopper usually sells for $900 and the store normally sells $50 each month at that price. We want to determine the selling price that will maximize the store's revenue. Okay? How many bikes will the store sell at that price? So we're trying to find a maximum value. So we want to come up with a function and like we've been doing all along, and find where this function has its maximum value. The trick to this question is to what you're going to choose your variable. In this question, you are going to let x be the number of times you increase or decrease the price. So in this case, we are decreasing the price by $20 several times. So let x be the number of $20 price reductions. And what we want to figure out from this is, how does this determine the price that we're going to sell each bike for, and how does this determine the number of bikes that are going to be sold? Well, if we are usually selling them at $900 and we reduce the price by $20 x times, our price is going to be 900 minus $20 for each reduction. So 900 minus 20x. X again is the number of reductions. Each time we reduce that price, we sell 2 more of them. So initially we sell 50 each month, but each time we reduce the price, we are going to sell 2 more. So our number sold is going to increase by 2 every time we reduce the price by $20. So we're going to sell 50 plus 2 times the number of increases, or sorry, the number of reductions. We want to maximize the revenue. So what we need here is we need an expression for the store's revenue. Well, the revenue is just going to be the price of each bike times the number of bikes sold. So if we have a price of 900 minus 20x, and the number sold is 50 plus 2x, that gives us an expression for the revenue. And we just want to find the maximum value of this function here. So let's put this into a form where it's a little bit easier to maximize. We've got these 2 binomials that are multiplied. Let's expand this out and collect our like terms. Doing that, we get 45,000 plus 800x minus 40x squared. Now, as I said before, you've seen this kind of question way back in grade 10. In grade 10, you would look at this and say, this is a parabola. I know because it's got that x squared term. I look at the sign of the leading coefficient. I can see that it opens down. So I would have to figure out some way of figuring out what the vertex of this parabola was. And when you found the coordinates of the vertex, you would know that those told you the number of increases, and then you could figure out the price and the number sold from there. Well, we have a better way of finding the vertex here, or that maximum point here in calculus. We are going to take the derivative, set it equal to 0, and solve. So our derivative, let's call this r primed at x, is going to be 800 minus 80x. Let's set that equal to 0, and let's solve for x. Bring the 80x over to the other side. 800 equals 80x, so x is going to equal 10. So this means that we're going to maximize our revenue when we decrease the price 10 times. So what is our price going to be? Well, price was given by 900 minus 20x. So if we fill in 10 for x, we get that our price is going to be 700. And if we do the same thing for the number sold, the number sold was given by this expression 50 plus 2 times whatever x is. So we're going to sub in 10 for x. And that tells us that we're going to sell 70 bikes. So we can sum all this up by saying, therefore, max revenue will, let's say, occurs when we sell, when, let's say, 70 bikes are sold at $700 each. And there we are. There's our solution. Now, what I don't like about this style of question is what we have chosen our variable to be. We're going to go right back up to the beginning here. Right at the beginning, we said, let x be the number of $20 price reductions. In the next section, we are going to look at a number of applications around business and economics. We are going to look at a number of functions associated with business and economics applications, revenue functions, cost functions, and profit functions. And in all of those functions, we always define x to be the number of things that are being sold or the number of things that are being produced. Here we have chosen x to be the number of price reductions. So choosing x to be this works very well in this case, but it's a less flexible approach, and it doesn't let you solve as many different types of problems, or the wider variety of problems that we're going to look at in the next lesson. So it's only good, really, for this precise style of question, which is why I really don't like this kind of question.